All right, welcome to Trailhead 2018. This talk is about Locker service. We're going to talk about developing and debugging on Locker service. My name is Jean-François Paradis, I'm also known as JF. I've been a developer on the Aura framework, the engine, the open source engine that powers the Lightning platform for a few years, and more lately, I've been focusing on Locker service. So before we start the talk, I have to show you this slide. Most of you have seen it. I won't go I won't go in all of the details, but overall it says, if you make purchase decisions, make them on features that are shipping. We're going to talk today about oncoming features and software development being what it is, inherently volatile. Timelines and feature can change at any time. All right, let's get right into it. We're going to cover 4 things today. We're going to do a quick review of Locker service, and we'll try to make it interesting for people who know the platform and people who are new to Locker service. Then we'll do a little bit of debugging and development, and we'll finish with the talk with the new features that are coming to Locker service. So first of all, what is Locker service? A bird's eye view of Locker service, if we imagine we are in the app builder and the developer has brought here, or the admin has brought 4 components. Locker service is the system that allows these components to share data and also blocks components from seeing each other. In this case, we have components in the A, B, and C namespace. So all the components in the A namespace can see each other, but they cannot see B and C, and vice versa. So this is what Locker service is at the bottom line of it. Now you will say, JF, why did we do that? Why not use iframes to do this? And you'll be right, because the iframe is the native browser security model. The iframe provides CSS isolation. Every iframe is independent. Independent DOM, independent globals, and other objects like cookies are all independent in each iframe. But this, for the type of development that we're doing, it's not optimal. So Locker service keeps the good part of the iframe. It keeps the DOM isolation, it keeps the global isolation, and the cookies and other things. But it solves 3 main problems. The first one is the fact that resource cannot be shared between iframes. So you would have to reload all your CSS framework for every iframe. So that would cost you at the time where you're the least willing to make sacrifice, which is Bootstrap. The iframe also is not optimal for content clipping. So if you want to do pull-down menus in an iframe, you cannot extend the iframe. It will clip the content. Same thing with hover state and maybe like you want to do some dialog boxes. So Locker service solves this. And those 2 things become extremely hard to deal with when we are doing something like what we do in Lightning, which is nesting components inside each other. So you might have one component from one namespace inside another component from another namespace, and so on. So imagine all of the orchestration you would have to do if you were to use iframes. So this is the goal of Locker service. Now, how does it work? There's many ways we can look at Locker service. If we take a look at the pipeline view, this is overall how it works. So imagine we load your code and we evaluate it in a secure context. So you have access to a secure global, which is yours. And then once your code executes, it has access only to some vetted API as raw API. And for the ones where we need to tweak a little bit in order to preserve the confinement of every namespace, we provide you with secure objects. Objects where the methods have been tamed in order to maintain that confinement. Now, those 3 things, we're going to dive a little bit deeper into them. So we're going to talk about strict mode and why it's enabled in Locker service by default. And then we'll talk about 2 objects, the secure window and secure element, which enable these 2 things. So strict mode is something that comes with the browser. It's been with us since ES5, so December 2009, if I believe. And it's not enabled by default. it's a different way of executing JavaScript. There's about 30 things that change. But we want to focus on 3 things. The first one is, and that will impact you, is running with Locker Service means that some errors that were silent will not be anymore. So your code might break if you turn it into strict mode. And the other thing is we need the strict mode to maintain the confinement of Locker Service. And we'll see what it means. Now, we enabled strict mode, and it's the way, and we believe it's the way of the future because it comes on, it's on by default when you use a new JavaScript feature like modules. If your code is made of module, it's in strict mode. Now, why we need the security feature? Here's a little quiz. Can anybody tell me what this will do, what this will return? Sorry? It depends where it's called from. Okay. Well, it depends where it's called from. Explain.
So whatever context called that function will be the context that this will have.
Okay, so wherever context this is called, this the this will depend on that context. That's one answer.
It actually returns the global object, which depends on the host.
That's also interesting, but the answer is also that it depends. It depends if you're evaluating your code in strict mode or not. So if you, do you have a timer going forward on this thing? So when we evaluate the code without strict mode, the old way of JavaScript says that this can never be something that is not an object. It cannot be a primitive. So the behavior of JavaScript is it climbs up and gives you your current window. But this is terrible for confinement because you can escape. Anybody can write this little line, evaluate it, and you get access to window. In strict mode, the requirement or the limitation around what this context can be are lifted, and if it's undefined, as in this case, it will return it. So this is why we need, so these are 2 reasons. One is for confinement, and also because we believe that it's better to move forward with strict mode and evaluation of the code, because it's the way of the future. All right. Now, what is that global environment? What is that secure global? So when your code executes, it has access to an environment where you can export data. So if you load a third-party framework like D3 or jQuery, it will be exported on your window. Now, in an environment where we have multiple components come from different namespace, we want to preserve isolation. So we give every namespace its own window object. So somebody loading a version of D3 will not be affected by somebody else loading a different version of D3 on the same page. And this is probably the simplest of the objects that we have in Locker Service, the global window. So every namespace get one. Now, if we take this to the next level, there we go. So the Sandboxed DOM is the next object, the secure element. So what's happening in this case, we want to do the same thing with the DOM that we do with the window object. So we want to provide a DOM that is different for every namespace. But the problem here is we still have to render something on the page. So we cannot just give you a DOM and then you do your things and then somehow there's going to be some magic that will multiplex everything again back to the page. So what we do in this case is we still use the real DOM, but every time you create an object, you have access to a filtering method that will, on the back end, tag every DOM element with your namespace. And then every method that returns either a DOM element or collection will filter the result and only return something that you have created. So this is why this is how we maintain isolation in the DOM between the different namespaces, as if we had iframe. So your component will, or your set of components will look like they're alone on the page. All right? Now, tricks to develop with Locker Service. Well, first of all, Locker Service is a security feature, and security comes always at a price. It's always the fight between access and security. Obviously, if you make something secure, you have to remove access in some places. So if you do your development, think early about Locker Service. See Locker Service as an enabler of security, something that will do some of the heavy lifting for you. And the benefit that you get is your component will be able to run everywhere on every one of our apps. Second thing, imagine that your code is now running in competition with others in the browser. So don't use polyfills that try to patch the browser. For example, Core.js is a popular library that tries to make all environments the same. And also try to avoid having global references like component IDs. Work with classes instead. And if you use CSS, prefix your CSS classes. There's a lot of tools online that can help you doing that. There's also a lot of utilities that you can put in your build process, your grunt job to sandbox your CSS to prefix it. So that will make sure that your code doesn't affect other people on the page. It's like we're back on the years of cooperative multitasking. We have only one thread. We all share the same resources, so we have to make some trade. And especially on the CPU, try to return the control of the CPU early. Try to make your code as async as possible. Your users will love it. They will keep using your components if you do it this way. Now, we also have a lot of resources you can take a look at for what we support in Locker Service. This is the API viewer. It's like a probe. When you load it in your page, it looks at all of the objects that you have access to, all of the things that the browser are born with, as we call them, the primordials. And it makes a diff between that and what we see in Locker Service when you load that browser. The things that are in red are things that are not supported, that are undefined, and the thing in orange are the things that are significantly different. So that's a good resource, and this is the URL where you can access it. And finally, we have a great set of resources available online. The Salesforce developer website, but also the Stack Exchange. We are active on Stack Exchange. There's a large community of people knowledgeable about Locker Service, and we also monitor and try to answer the questions that are asked on the platform, on Stack Exchange. So Locker-Service should be a tag there. Now, a quick review on debugging. I'm going to mention only two things. Surprisingly, they're not well known. The first one is that you can turn Locker on and off easily. By default, it's enabled. So what you do here is, on the right side here, we are in Developer Console. The last item at the bottom of your resources is the settings, and you can change the API version to any number below 40, and Locker will be disabled. So you can use that to debug your code, see what's the behavior Locker on, Locker off. Next thing, if you put a break in your code, you can check what is the status of the environment. So in this case here, imagine I have a breakpoint, and in the console, I just do window toString, which I simplify by forcing a typecast with a plus empty string. If Locker is enabled at that point, you're going to see an object window, as you should see, if Locker wasn't there. And otherwise, you'll see something like secure window with the key being your current namespace where the code is executing. And from that point, you can call every method. You can inspect the window. You can see what is in your sandbox. A document will be the same, will be sandbox. If I output document plus empty string, I'm going to see secure document, and so on. So it's a great way to inspect what's going on in your code. All right? Finally, let's talk about what's coming with Locker Service. Next release, we're going to bring eval back. We thought we could not do it initially. We found a way to make it secure, so you can use eval in your code. But there's going to be a twist. Eval will not work exactly like the real eval. It will always be a global eval or an indirect eval, as it's properly referenced. So in this case, the first example here, the eval has access to the current function context. So that's the direct eval. The other line where we do the 0 comma, which is the dedicated or the classic way of forcing an indirect eval, the eval is done in the global context, and Locker service will be in your global context. And the reason why we bring it back is there's a great study, the eval that men do. Take a look at it. It's a survey of the top 10,000 Alexa-ranked websites, and their conclusion is that eval is extremely useful, extremely used out there, and that's why we're bringing it back. We're also going to simplify debugging next release. So on the left side, this is the current state. We have to preserve confinement. We have to wrap your code with a lot of boilerplate code or a lot of wrappers. And this is gone. Next release, you will have the code as is, either both in your own eval and if you do your Lightning components. After that, coming maybe next release, the next release after will bring CSP and Strict CSP. So CSP is a set of browser features, a set of policies that we can turn on and off at very granular level in the browser. There are two that are extremely important, unsafe eval and unsafe inline. Unsafe eval, we solved it. Unsafe inline, we have to do it. And unsafe inline is basically about preventing the XSS attacks, type of attacks. So what this is about is the HTML by default allows multiplexing. It allows code that is HTML, CSS, and JavaScript to be mixed together. And when we talk to our security reviewers, they always say, if you want to find a way inside a system or a workaround for some security features, look at the boundaries between systems. And when we inject HTML, it's extremely easy to make a mistake and add some JavaScript code and not use a sanitizer. Like all frameworks today sanitize whatever is going to be output in the DOM, but it's extremely easy. There's so many points of entry, it's easy to forget one. So by disabling unsafe inline, we prevent that type of attack. The browser will, no matter what's happening in the framework that you're using, the browser will prevent the JavaScript to be executed. So that's going to come. It's going to be a feature that we're going to allow you to turn on and off. It will be on by default, and you'll be able to disable it. And after that, we'll bring something else, which is called the frozen realm. The frozen realm is a new specification that's currently in the work. Salesforce is participating to it. And to simplify it, it's basically all primordials, all objects the browser are born with have their prototype frozen, cannot be modified. This allows a lot of resource sharing between the different contexts. It prevents tampering. You can look at the specification being worked on. We believe that the browser will eventually support it natively, but we're going to bring it as a library, as a section of Locker service in the near future. So in order to be ready for this environment, avoid modifying, as I mentioned before, the prototypes, the native objects of the browser. And if you load something, if you load a feature that is a new feature, if you bring a polyfill, make it optional. This is a simple line from the promise polyfill. And in this case, before trying to override something, we'll look if it's there. So that not all polyfills do it. All the good corporate citizens do it, but not all of them. So in your code, look for that when you develop. Try to make your code feature-proof. All right, that's all I had for you today. Last thing, we have great modules on Trailhead. This is about developing for AppExchange. It talks a little bit about Locker service. I invite you to take a look at it. You might find some great ideas how to make your code secure. I hope you like it. So, thank you. Are we opening the mix for questions? Yes? All right, let's go for questions. Like it's a section of Q&A.
So, like when you explained about the components, and I think you were saying that every component gets its own
Namespace.
secure window.
Yes.
So, how are you like handling performance in this? Because we are having to create multiple layers of API on top of the existing window objects, right?
Yes. Now, performance is a complex problem to solve in something as big as Locker Service because of the just sheer amount of API we have to cover. The result, the truth is, our measures show that we have performance reduction in some APIs that is not that great, but most of the time it's pretty good. So much that on a regular page, if you load like 10 components, you will barely see an impact. For example, if you use HighChart, a very popular library to create charts, locker on, locker off, it's below 1% difference. We also, in our code, try to be very efficient at bootstrap time, and we don't instantiate Locker Service unless it's used. And we only create the namespaces on demand as they are used at the first time of the evaluation. So that's how we mitigate for performance. And we're always improving. There are things that are coming that will make it even faster. Like the eval that I'm talking about, the new eval that's coming, it's a lot faster than the previous one. We found some ways to save some time here and there.
So once we're in the world with Frozen Realm, and we shouldn't use polyfills because the prototype's locked, and the recommendation to avoid that is using transpilers like Babel. What does Salesforce development look like using transpilers?
That's a big question. You can use polyfills as long as they don't override existing objects. So if you bring something else, if you bring something new, like in the case that I showed of the promise, it's all good because you're not going to override something that exists. If you're trying to patch something that exists, that's where the problem is. Today, it's less, something like Core.js is less important in the world of evergreen browsers. And Locker Service is currently disabled on i11. So it doesn't even run on i11. We made the decision to leave it off. So we focus on evergreen browsers. So that reduces the problem. And transpiling, well, if you bring your code if you have a third-party library, you can transpile it. We're doing that internally for some larger libraries. But overall, the trend is just go for the evergreen browser and don't worry about the transpilation.
What about like support for TypeScript development?
John, do you want to answer this one?
Does Salesforce provide the transpilation, or
We don't.
You have to bring the transpilation.
You have to do it in
yourself?
your code, yes.
So then I think that answers the TypeScript question as well.
Yes.
So you would do the transpilation on the TypeScript, and then you would bring the transpiled ES5?
Yes, currently it's ES5,
JavaScript?
yes. But you can have, if you bring
that.
a library in that you load with as a static resources, we don't do anything with it. So you can have ES6, ES7 features in there. We don't impact, we don't touch it. And Locker Service is ES6 compliant anyway. So any code running in ES6 will run inside Locker Service, given that it's not hitting one of the security features that we try to enable. Make sense?
Yep.
If you have a specific problem you're hitting, talk to us. We won't. We in the lookout for these kinds of limitation, and we're trying to always expand the capabilities of Locker Service.
Okay. Yeah, I'm not running into a problem, but I'm just trying to figure out what's a good developer experience for using something like TypeScript, where we're developing locally, but really we have to push it into the cloud before we can even run our code.
Yeah. Good.
Ideally, it's transparent.
Other questions?
Yeah, my concern is we're planning to use a JavaScript library, but we don't know how much testing to make sure it works well with Locker service. And
Yes.
we don't want to get to the point where we're overly committed and we realize it doesn't work with Locker service. So what are the telltale signs that a library works well?
Tomorrow, the future. So we are we are currently developing tools to allow you to solve your problem. Tools that will allow you to load the library or its test suite inside of an environment and run their test suite and see how it goes. And maybe also some tools that allow you to use your own test framework. So maybe you do something with Jest in your own code, and you have your own test suite. So we're working on this. Currently, you have to find a way to either scan the code, look at what we support, and just also think about how that library that you're trying to use is impacting the environment. If it's something that's trying to sniff the browser environment, for example, there's a lot of people who want to do something that looks for performance, how many XHR, what is the rendering time, and all of this. In order to enable that type of library, they have to modify the polyfills, and this is kind of not the security model we're trying to implement. We don't want people to sniff on other people's data. So we're going to have to find a solution for these cases, because currently all you can do is turn off Locker. But most of the libraries that we have found so far that are about showing UI, like HighChart and D3, are working fine in Locker service at this point, because they're not inherently trying to hit security boundaries.
Yeah, I ran into a case with Google Maps.
Well, yes, Google Map, exactly, yes. Google Map, Google Tag Manager, all of those things are inherently developed for the free-for-all view of the browser, where everything is global, it's easy, but there's no security. Yeah.
So there was one thing that I didn't understand. In your do's and don'ts, you said don't use IDs.
Yeah, global IDs,
global
yes,
IDs.
yes.
But then you said everything, I thought you said everything was tagged with a namespace.
Yes.
So I don't-
So what's going to happen if you use IDs is you're going to enter into a mode where you're going to create an ambiguity in your code. So within Locker service, everything will be tagged, so we should be able to return you the elements with your global ID. But in the case you decide to turn on Locker service and somebody else has used that tag, then you're going to have a limitation. A query selector all is the same thing. You want to, if Locker service is on and off, the results will be different. So you want to reduce ambiguity. So try to avoid using global for that reason.
Or for any JavaScript.
More questions? We still have what? Are we done? 5 minutes, 5 more minutes? All right, if there's no more question, I'll be available. I'll be walking on the floor. Come talk to us. We love to hear your stories. We love to help you solve your problems. Thank you very much.